Everyone, welcome back to my class. In today's class, we are going to do second factor, that is species area relationship of other attributes of biodiversity. What is species area relationship and who gave it? It was given by Alexander von Humboldt. Who was Alexander? He was German naturalist as well as the geographer. He studied in the jungle of South America. So in the jungle of South America, he studied something. What was that something? He studied the relationship between species and area. By that, he said that species richness. Now, what is species richness? We already did this in the previous class. Species richness is nothing but the number of species. Okay, then more number of species, that means more species. Now, when I say number of species, do not get confused. I'm talking about the more diversity of the species. Okay, more the diversity of species, more is the going to be the species richness, right? So what did he say? He said that species richness increases with increase in area. He explored the jungle of South America. In that South America, what did he do? He saw that species richness, species diversity increases with increase in area, but only up to the certain limit. After that, there won't be any increase in the number of species, right? See here, for example, I have taken area A. So I saw 20 species. I increased my area B. I saw 40 species. I increased my area until C. I saw 48 species. Beyond this, when I increased my area, I did not see any increase in the species. So that now the species level is constant, right? Now let's quickly revise what we studied in the species richness. Species richness is nothing but the number of species. The number of species, when I say it, automatically it should strike your mind that I am talking about the variety of species. That means diversity in that, right? So species richness is nothing but number of species per unit area. We call it as species richness. That means in an area, how many number of species you have, more the number of species, more will be your species richness, right? More the number of species in an area, more is going to be species richness. So can I write this? More the area, more is going to be species richness, right? Now see here the slope. I told you that Humboldt said species increases with increase in area, but only till certain point. Why did he say that? Because if that doesn't happen, then my graph will come J-shaped graph instead of hyperbola. Instead of rectangular hyperbola, I would have got J-shaped graph. So species richness increases when an explored area increases. See, this is your species richness on y-axis and area on x-axis. As I am increasing the area, my species is increasing. But it should not keep on increasing, otherwise it is going to give me J-shaped graph, but my J-shaped graph is going to be wrong as I don't want J-shaped graph. My species richness versus area is not going to show J-shaped graph. If it shows J-shaped graph, that means it is wrong. It is going to show hyperparabola graph, right? Rectangular hyperbola. In fact, the relation between the species richness and area for a wide variety of taxa, that is your angiosperm, plants, birds, freshwater fishes, all these turn out to be non-linear graph. What is the meaning of linear? This kind of graph, when it comes, we call it as linear graph. But what did I tell you? Let me show you the graph. This is how your graph looks like. Is it linear? No, this is obviously it is not looking like a rectangular hyperbola, but your textbook says it is rectangular hyperbola, so you have to remember it as like a rectangular hyperbola, right? So here this is going to be your graph, that is rectangular hyperbola. Is it linear? No, it is not linear, so we call it as non-linear. On logarithmic scale, the relationship is straight line. So when you see this graph, so this is the graph of Let me clear this. This is the graph of species richness versus area. Plot species richness on y-axis and area on x-axis. You saw that as the area is increasing, my species richness is increasing. See here, it is increasing, increasing, increasing. But here if you will see, it becomes constant no matter how much area you are increasing. See, from here to here I increases the area, but there is no increase in the species. So we call it as no matter how much, like only until certain point your species richness you will see. After that there won't be any increase in the number of species, no matter how much area you are going to increase. Correct? So this is your graph for species richness and area. What is the equation of it? The equation is going to be your S, that is species richness, is directly proportional to area. That's what I told you, right? Species richness is going to increase as we increase the area until the certain point. So species richness is directly proportional to A raised to the power Z. Now, if I want to remove this proportionality sign, you must have studied in the physics, I have to put some constant, right? So S is equal to C. Instead of proportionality, now I have kept over here C A raised to the power Z. This much is clear. This graph, when you will plot, it is going to give you rectangular hyperbola graph equation. But the scientist converted this graph into logarithm graph. Now, what was the reason for him to convert it into log? Why we did not stop it over here? Before moving ahead, let me tell you, Z is nothing but your slope of line or regression. Regression means getting down, decrease, okay, decrease coefficient or slope of line. By this, you have to understand what is the meaning of slope. Slope is nothing but class. Let me draw it over here. Suppose if I am drawing a line over here. So this tan theta is going to give me slope. This tan theta is going to give me slope. Suppose if, let me draw another over here, this one. So can you see the theta increase for this? That means slope also increase. This blue one is steeper slope. Steeper मतलब होता है class खड़ा हुआ. Like you know, it is more, it is steeper as compared to the red one. That means आप देख सकते हो यहाँ पे it is not खड़ा हुआ, but this one is खड़ा हुआ को हम बोलते हैं steeper one, right? If I am going to draw the third one, then over here it is going to be more steeper as compared to the blue one. He ज़्यादा खड़ा है as compared to the blue one. So this we call it as, this is going to give the slope. This is going to give the slope, right? Slope is nothing but which makes angle, and it is going to give the value of tan theta, okay? And it also tells you the direction, but now we don't want to study that. Now listen to me very carefully, that when we already have an equation, when we already have rectangular hyperbola graph, what was the need for us to convert it into log? Now what was the need? Let me tell you. See here, if I increase the area, species increases. I am getting the value, right? Now let me increase the area more, species increases. I am getting the value, right? Let me increase the area more, I am getting the value, right? Now here I am increasing the area, species increases. Here when I am increasing the area, can you actually tell me how many species are increasing, or it's constant or what? No, you cannot say. I'm just increasing the area. So it is not telling me how many number of species are being added or increased when we increase the area. That was the reason we have to convert this equation into logarithm. Let me erase this and tell you. See here. Now, if I'm going to draw here, increase in area giving me increase in species. Increase in area, it is giving me increase in species. Increase in area, it is going to give me increase in species. Now there is no confusion, but did you saw over here there was a confusion. I was not getting how many species are being added as we increase the area, right? So there was no clarity about it. That was the reason we converted this equation into log equation, right? That was the reason we converted it. Now this log equation is going to give me straight line graph, and this straight line graph is helpful for me to find out in a particular increase in the area how many species number increases. Correct? Now So see here, let's come to the equation now. When we convert into log, we have written log S over here, then log C over here. When we write for log for a raised to the power z, z will come first. Okay, so z will come first and we write log a. Right, so this is the equation for your species area relationship. Which equation? Logarithmic equation. Now this equation is going to give you straight line graph. By this straight line graph, it is easy for me to figure out how many species are increasing per area. Right, now this equation is actually equal to y raised to the power c mx. This is the mathematical expression or mathematical equation for straight line. Wherever you have straight line graph, this is it should follow this equation, that is y is equal to c mx. So here your y is log s, then c is your log c, and then m is your z, and x is going to be your log a. Now, what are these all alphabet mentioned over here? S is your species richness, A is your area, Z is your slope. Slope is what? It is going to give me the value of tan theta, right? Now, C is what class? Intercept on Y. Let me show you over here. Now, suppose this is a graph. If I am going to draw another line like this. So this is going to intercept on y-axis. Here the natural graph it is not showing, right? So this here the graph which I have drawn, this is going to intercept on y-axis. This is your C. This is your C. That is your intercept on y-axis. I hope I am clear with this, right? Now let's see this graph carefully. Let me erase it. Okay, see here class, as the area increases, your species number increases only up to the certain point and then it stops increasing. If I further want to find an increase in area, how many species is increased, we are not able to find it. That's the reason I have to convert this equation into the log equation. So when I converted this equation into log equation, it is nothing but y is equal to c plus mx. Y is equal to c plus mx. Now y is equal to c plus mx is nothing but your straight line equation. Straight line equation. What now with respect to the NEET, this equation is very important. They are going to ask you what is S or what is C, what is A, what is C. So you are supposed to remember S is your species richness, C is your intercept on Y, A is your area, Z is your slope or regression coefficient. Regression means decreasing one. Regression means it is going to decrease. Okay. Now, see here. Log S, species richness. Log C, it is intercept on y-axis. Z is nothing but your slope or regression coefficient. That means increase, decrease, right? Regression means decrease, right? And log A is your area. Now, Z is always going to be constant. Let me show you over here. See. Okay, so let's see this equation first. Let's finish the graph. Let me change. Okay, so here S is equal to CA, that means it is going to give non-linear curve, that is your rectangular hyperbola. But logarithm equation is going to give you straight line equation, that is linear relation. Linear relation. Why we did that? For easy understanding. What is slope? Slope refers to the slant or incline. Now, in a graph, suppose this is y-axis and this is x-axis and I am drawing a graph over here. So this incline, this slant we call it as slope, which is going to give me the value of tan theta, right? It describes both steepness. Steep kya hota hai class? Now this is one graph. See, graph number 1 and let me know graph number 2. Now this I am drawing it over here. Now tell me which one is more steeper, 2 or 1? Of course 2 is more steeper. Steeper matlab khada hona. Kitna khada hai graph, right? And the slope also tells you the direction, whether it is going to the positive direction or negative direction, but we are least bothered about learning this. What you have to learn, you have to remember the equation. With this equation, which kind of graph is formed, that you have to remember. Logarithm, you are going to get linear graph, and then you have to remember that S represents what, C represents what, A represents what, and Z represents what, right? Now, value of z is always constant and it remains in the range of zero point 0.1 to zero point 0.3. Regardless of any taxonomic group the organism is present, always z is going to be same, whether it is California or New York. Let me show you over here. One second. See here, whether it is California, I have not drawn California, okay, let it be. Whether it is New York or California, no matter wherever it is, always Z value is going to be in between your 0.2 to, 0.1 to 0.2. Right? Species area relationship among large area. This is among the small area, or it is constant for everyone. But when you want to calculate species area for larger area, let me show it over here in the graph. So it is constant between 0.1 to 0.2. Okay, but whenever you are going to take larger area, that means suppose I am taking, if I want to find the slope for the continent is a large area, right? If I want to find it for particular ecosystem, it is always going to be 0.1 to 0.2. But if I want to find for the larger area, that means towards a continent, then my z is going to be changed. My z value is going to be changed. My z value will become 0.2 to 0.1. That means my z value increases, right? So species area relationship among very large area like entire continent, the slope of line is going to be much steeper. पहला कैसा था, यहाँ पे slope was like this, but when we talk about the larger area, it is going to be more steeper, और खड़ा हुआ मिलेगा आपको. Why? Because the value of z increases. Right? So the at country level, if I see, suppose if I want to find only in India, it's going to be 0.1 to 0.2. If I want to check for the continent level, it is going to increase, that is 0.6 to 0.2. More steeper graph you will see here. At the tropical rainforest, Z value or Z value is going to be 1.15. That is the most. Okay. So where is the highest Z value? At the tropical rainforest. Right? Example you can see here, see the graph over here. This is the value 0.2, then 0.6. This is the Z value, right? Hypothetical value is given. Then Z is equal to 1, Z is equal to 1.2. Can you see as the value of Z increases, more steeper graph is. जैसे जैसे value बढ़ रही है, वैसे वैसे तुम्हारा जो slope है वो खड़ा होता जा रहा है. See, this is more steeper as compared to this one, or as compared to this one, or as compared to this one. ज्यादा खड़ा होने को हम बोलते हैं steeper, right? Now see here. For example, frugivorous, that is fruit eating birds and mammals in tropical forest of different continent, the slope is going to be 1.15. So what is going to be Z value for frugivorous or for mammals? It is going to be 1.15. But where? In the tropical forest. You have to remember this. This is the highest value of Z, right? Now, what about the steeper slope? When we are going to get steeper slope, what did I tell you? Steeper slope means the value of Z will be increased or high. More the area, more will be the species richness, more will be the Z value, and more steeper will be the graph. Suppose if I have taken this area, so only less number of species will be present. So my graph will be like this. If I am going to increase the area, more number of species are going to be present. So my graph is going to become steeper. Now, if I am going to increase more, then my graph is going to become more steeper. Getting my point? This is what is written over here. Steeper slope. The graphic representation explains relationship between species richness and area. In a specified area, the relationship between S and A is being shown in this graph, right? The curve shows that species richness increases with increase in the area, but only up to the certain level. So class, from here I have copied your textbook, okay? Now, only till the let me read it again. The curve shows the species richness increase with increase in the area to a certain extent and approach an equilibrium. Once the equilibrium is reached, there won't be any increase, right? It does not indicate the specific rate at which species richness increases with reference to the area. So just now I told you, if you will see this graph, so this graph is not going to tell you how many species are added over here. Suppose if I increase the area from here to here, am I able to find how many species are added over here? No, it is almost same. Almost same. That was the reason I converted this graph into log graph, right? Okay, now the slope of the graph drawn between log A and log S is your Z. So what is Z? Z is nothing but your slope. Increase in the slope indicates increase in the Z value, which means increase in the species richness. Just now what did I tell you? Increase in area is going to increase in your species richness. That means increase in your slope, right? Example, if log scale makes 45 degree with x-axis, then z is going to be 1. So this is going to be your 45 degree when theta, when tan theta is 45, it is going to give value 1. Z value is going to be 1. If the slope value is more than 45, that means if I take this, then Z value is going to be more than 1. If the value of the value of Z in tropical rainforest is more than 1, that means this 1.5 is the value of tropical rainforest. So slope will be more steeper. So increased slope will be there. Steeper means khada hua. That means increased slope will be there, right? So that's all we have in today's class. I hope you must have understood about your species area relationship. It is nothing but class how species richness is related with increase in area. More the area, more the species richness, but only up to the certain level. Then what was the need for me to convert into log? Because I was not able to understand with this rectangular hyperbola graph. I was not able to understand how many species are added after certain area, right? After certain point, if I am increasing the area, I am unable to find how many species are added. So I converted this equation into the log form, which gives me the straight line equation, and now my graph is straight line. Due to this straight line or linear graph, easily I am able to find with an increase in the area how many species are increasing. How many species are increasing? See, if I increase area from here to here, then these many species are being increased, right? So that's all we have in today's class. For next class, we'll see another topic. Thank you.